Hello and welcome back to Diksha Vedantu Foundation channel, and you are watching 99% in 99 days. So I am going to discuss all the questions of physics from the sample paper number 10, and whatever doubts, questions that you might have, you can post in the comment below. Definitely I will try to answer all of your comments. Okay, so without any delay, let's start with today's class. Your final board exam is approaching, so obviously you want to practice more and more. We have done, this is the 10th sample paper for science, so I hope your science paper will be sorted. So let's see what are all we are going to discuss. In the 1 marker section we have 5 MCQs and 1 assertion and reason based, to total 6 marks. From 1 marker section we have 2 marker question, we have 3 2 marker question, we have 2 3 marker question as well. We have 1 5 marker and 1 4 marker question, so total is 25 as usual. So in the last paper we have seen the number was slightly above the denoted 25. So this is a very standard paper. So let's start with the 1 marker section. That is MCQ. How will the image formed by a convex lens be affected if the upper half of the lens is wrapped with a black paper? We have answered the similar question in our previous sample paper, but that was a long answer type question. I think 3 marker or 5 marker, I don't remember, but that was a slightly longer format. Now the same question they have asked in the MCQ section. So as you know that even if you cover half of the lens, it does not matter, the lens will still operate as usual. Only thing is the lens, the brightness of the image formed will be less. Okay, brightness depends on the full opening. If the lens is fully opened, then obviously the brightness of the image formed is slightly better, but if you have covered the lens half or based on your requirement, it will still work as usual. Okay, the image of the upper half of the object will not be formed. The size of the image formed will be 1/2, not correct. Image formed upper half of the object will not be formed, not correct. The brightness of the image will be less. Okay, so that is the correct answer. The lower half of the inverted image will not be formed. So these are not correct. It will work as it is. Only thing is the brightness will be reduced. You can still see the image formed as usual. Now let's move on to the next question. The phenomena of light involved in the formation of rainbow. Okay, so we have seen this question in my regular lecture as well. So what are all involved in the formation of rainbow? Okay, refraction, dispersion, scattering, and total internal reflection. Okay, so let's see, is scattering involved in the total internal reflection? No, scattering are not involved. So only thing that is involved is basically refraction, okay, then dispersion and total internal reflection. Okay, so first what happens is light comes from this is the water droplet, this is the sunlight coming into the water, and then it gets dispersed. Okay, so after it gets dispersed into 7 constituent colors, individual colors get total internal reflected. Okay, based on obviously the incident angle. Okay, in this case it's slightly, so after the total internal reflection, okay, they come out of the rain light. So basically what happens is, this is the white light, this is first refraction, then there is a total dispersion. So this is dispersion, then there is a total internal reflection, and there is another refraction happens on this edge, but we generally do not consider this refraction. This is not important. Main important is the first refraction, total internal reflection, and in between dispersion. Okay, so from the given option, refraction, reflection, dispersion, no, not correct. Refraction, dispersion, and internal reflection or total internal reflection. So that is the correct explanation. Okay, reflection, dispersion, and internal reflection. Reflection, here they have given the almost same, very tricky to fall for the trap. This is reflection, refraction, dispersion, scattering, and total internal reflection. So total internal reflection they have mentioned here, only internal reflections are mentioned, but they are on the other, they are same thing. Okay, so refraction and dispersion is there. Scattering does not happen inside the bubble. Okay, scattering might happen before and after, after this scattering might happen. Okay, but that is not important for a formation of rainbow. Now, the color of light for which the refractive index of glass is minimum. So options are red, yellow, green and violet. Now we know that the refractive index, the wavelength for red is maximum, highest, okay, from the all visible light of light. Lambda for red is highest, lambda for violet is lowest. So lambda h represents is the highest wavelength, lambda l represents the lowest wavelength, yellow and green comes in between. So only thing that we need to consider is which one will have the higher refractive index. Okay, so the question is refractive index is minimum. Now refractive index of a medium is basically inversely proportional to wavelength. Okay, higher the wavelength, lower is the refractive index. Okay, how do you represent refractive index? You can represent it using mu or n. Okay, in some books they represent refractive index using mu, and some books they use refractive index using n. Okay, in higher classes maybe we will use it only for n. Mu, if you are using mu is also fine, but you have to remember that refractive index is inversely proportional to wavelength. So higher the wavelength, lower is the refractive index, and as you can see that red will have the minimum refractive index because it has highest wavelength. Okay, now the current carrying device which produces a magnetic field similar to that of a bar magnet is. Okay, current carrying device which produces a magnetic field similar to bar magnet, which is equivalent to bar magnet. Which one? Obviously solenoid, right? So not state conductor, not circular loop, only solenoid, which is equivalent to a bar magnet. Okay, circular coil is also not. They will have their magnetic fields, but a solenoid behaves like a bar magnet. Their magnetic field lines are very, very similar to that of a bar magnet. Now next question, this is a unique question. Okay, and I think this question is slightly higher level than your current class. This is slightly older sample paper, so that's why this question, this was part of the syllabus, no longer part of the syllabus. Anyway, let's see. Uniform magnetic field exists at the plane of the paper. In this field, the electron E and positron P enter as shown. The electron and the positron experiences forces. Both pointing into the plane of the paper, both pointing out of the plane of the paper, pointing into the plane of the paper, and plane of the paper, out of the plane of the paper respectively. So first we are talking about electrons, then we are talking about positrons. Okay, next they have given pointing out of the plane of the paper and into the plane of the paper respectively. Now let's see the diagram. Okay, so magnetic field is given in this direction and electron is moving here in this direction, positron is moving in this direction. Now if electrons are moving in this direction, then you can consider that the current is actually flowing in this direction. So in the case of electron, the current is flowing in this direction, right? Electron and current, they generally flow in the opposite direction. So flow of electron is basically opposite to that of flow of current. Similarly, in case of what should I say? Positron also, it is flowing in the current in this direction. Okay, so positron is already positive. Positively charged electrons are called positron. Okay, so basically obviously positively charged electrons are not super common, they are antiparticle of electrons. So but don't worry about it, positively charged proton can also be considered to be positrons. Okay, now you have to apply your left hand rule, Fleming's left hand rule, to find the direction of the force acting on this electron. Okay, so based on that you can say whatever is the force acting on the moving charges, that is the left hand rule. So basically what first of all you have to do, you have to convert this into the motion of current. So you have to understand that electron flowing means current is in this direction. Now as you can see, both the current in the same direction, so force on both cases will be same. Force on both the charges will be in the same direction, because current is in the same direction. Now how to do that? You have to use Fleming's left hand rule. So this is the direction of magnetic field, this is the direction of current, so the force will be into the page of the paper. Okay, so this is the magnetic field, this is the current, and this will be into the page of the paper. You have to orient your fingers such that you can answer this question. Okay, so both pointing into the plane of the paper, both pointing into the plane of the paper. Very careful, don't mess it up. Electron and positron, that means electron is flowing in this direction, means current in this direction. Maybe they will change the question, they will give one having current in this direction, current other direction. If the current direction is opposite, then definitely the force will be in the opposite direction. Okay, now in this case, because current direction in the same pointing towards the same direction, the force should be in the same direction as well. Little complicated, but you can answer it with little bit of extra information. Now let's see assertion and reason based question. Electrons move from lower potential to higher potential in a conductor. A dry cell maintains electric potential difference across the ends of a conductor. This is a very common assertion and reason question. I have solved this at least 2-3 times before as well, and many students get confused and they said both of them are correct and it is the correct explanation. So let me clear that yes, both of the statements are correct. Electrons definitely move from lower potential to higher potential, and current flows in the opposite direction, that is from higher potential to lower potential, as well as a dry cell maintains a potential difference across the ends of a conductor. That is fine, but the property by which electron moves from lower potential to higher potential, it has nothing to do with the dry cell. As long as there is a potential difference, electron will always move from lower potential to higher potential. That can be done by a dry cell, that can be done by external charge that is present there, that can be done by some distant electric field present, maybe due to cosmic rays, whatever it can be. If there is an electric field, it not necessarily due to a dry cell, it can be wet cell, it can be lithium cell, it can be any static charge present at there. Okay, because of whatever reason it is, if there is an electric field, okay, if there is an electric field maintained, and electrons will always move from lower potential to higher potential. In case electric field is varying also, electric field is not constant, in that case also it will always move from lower to higher potential. Okay, it does not matter who is maintaining that electric potential, whether electric potential is constant or not, does not matter. As long as there is a potential difference that can vary with distance, vary with time, does not matter. Okay, electrons will always move from lower to higher potential. Okay, it has nothing to do with the dry cell. That is the property of an electron. Very clear in your head. Whereas dry cell is an external device. Okay, if you say that a current is maintained in a circuit and dry cell maintains potential difference, then you can relate it to the Ohm's law. V is equal to IR. If V is constant, then definitely I will be constant, resistance of a circuit is constant. So in that case you can say, okay, assertion and reason are reason is basically the explanation of assertion, but they are not talking about current in assertion, they are talking about electrons. So electrons move from higher potential lower to higher potential because of their property and nothing to do with the cell. So both statements are correct and R is not the correct explanation. Okay, as I said, it has nothing to do with the dry cell. If you still have the confusion, please check this video once more. You can recap this video and listen to me once more. Now section B, 2 marker section. The heat produced at a point due to the concentration of sunlight by a convex lens burns a paper. So we know that if we have a convex lens like this and some sunlight is falling on it, okay, if you place some paper, okay, the sunlight actually get focused at this point and it burns the paper, right? We have seen that, we have done that. That was one of our favorite pastime when we were kids, right? So explain why it happens. Now they have asked you the explanation. Name the term in the context of the lens used given by the point at which the paper starts burning. What does the bright spot formed in the paper represents? Let's see. So convex lens converges sunlight to a single point that is called focus. Okay, concentration concentrating the energy and producing a sufficient heat to burn the paper. Okay, the point is called focus of the lens. The bright spot is the image of the sun formed at the focal point of the lens. Very, very important. So whenever you are focusing the sunlight onto a paper, basically what you are doing, you are forming an image of the sun. Now sun is very distant object, so for us obviously, even though it is measurable, it is not like a distant star, but still it is very, very far away compared to the distance from your paper, right? So paper distance is 20 centimeter, but that is 1000 kilometers, right? So basically that is why you can consider the rays that is coming from the sun to be parallel, and once it is falling on the lens, it gets converged exactly at the focus of the lens, and then it forms a very tiny image of the sun. We know that when object is at infinity, a tiny image forms at the focal of the lens. So that is basically the practical application. Now let's see. An electric source can supply a charge of 500 coulombs. If the current drawn by the device is 25 milliampere, find the time in which the electric source will be discharged completely. Let's see the answer. So given here is 500 coulomb. Okay, current is given as 25 milliampere. Now milliampere is not a standard unit, so you have to convert it into ampere. What is ampere? Milliampere to millimeter to meter, 10 to the power of minus 3. Milliampere to ampere, 10 to the power of minus 3. So milli is basically represents 10 to the power of minus 3. So milliampere to ampere is basically 25 into 10 to the power of minus 3 ampere. Time taken is basically Q by I. So if you calculate 500 divided by 25 into 10 to the power of minus 3, that is 20,000 seconds. 20,000 seconds. Okay. And then convert, so basically you can cancel it. 25 is 20 into 10 to the power of 4. So what happens when you divide by 10 to the power of minus 3? Many students confused. So 10 to the power of minus 3 becomes plus 3. Okay, when it is divided, it goes up and it becomes positive. Similarly, if you divide with the positive 10 to the power, it goes up and it becomes negative. Okay, this is how we exchange. That is why 10 to the powers are preferred in case of scientific calculations. It is easier for us to convert. Okay, converting seconds into hours. Now if you convert it into hours, it will be closely 5.56 hours, but this is optional. Okay, this part is definitely compulsory. This part, the second part, is optional. So the electric source will take approximately 20,000 seconds to discharge completely. That is the main answer. Okay, but if you want, you can convert it into hours also to showcase that you can do that. Otherwise seconds has to be there, right? Next question, section C. Study the diagram given below and answer the following question. What is the diagram? So this is the diagram. As you can see, the near point has shifted. So now whatever object is kept at the original near point, it is forming an image behind the retina, right? So what is the type of defect? You have to answer. Name the defect of vision depicted in the diagram and state the part of the eye responsible for this condition. List two cases of this defect. Name the type of the lens used to correct this defect and state its role. Or what is the dispersion of white light? State its cause. Draw a diagram to show the dispersion of beam white light by a glass prism. Okay, so these are the all standard question. Let's see. First is defect is hypermetropia or farsightedness. Okay, so basically he cannot see the nearby objects, but he can see far objects. That's why it is called farsightedness. You can see the far objects, you cannot see nearby objects. Okay, so hypermetropia. The eye lens fails to focus the light properly on the retina. So which part of the eye is responsible? It is basically eye lens which is responsible, because it cannot focus the rays that is coming closer to your eye to your retina. Okay, causes the eyeball is too short, reducing the distance between the lens and the retina. The eye lens loses its converging power. Not super convenient, but you can say that ciliary muscles are not able to adjust for closer objects. Okay, that is the main reason. Now convex lens is used to correct hypermetropia. It converges incoming light rays before they enter the eye, enabling the image to form on the retina. Basically, a convex lens can fix the hypermetropia, and concave lens can fix the myopia. Dispersion, or now or question, dispersion is a phenomena where white light splits into its constituent colors, that is Vip gear, when passing through a prism, cause different wavelengths of light refract by different amounts due to varying speed of the prism in the prism medium. Now diagram, the diagram shows white light splitting into 7 colors. So this is the standard diagram. So a ray of white light coming after falling in the first, it separates into 7 colors, and that thing continues, and you get Vip gear in the opposite order. Order is very, very important. Okay, Roy G B I V, Roy G B I V, or you can say Vip gear from the bottom. Next question, what happens when a bundle of, this is a OR question, right? Yeah. What happens when a bundle of wires of soft iron is placed inside a solenoid carrying a steady current? Name the device obtained. Why it is called so? Draw the magnetic field lines inside a current carrying solenoid. What does the pattern of magnetic field lines indicate? Let's see. So when a bundle of soft iron wires is placed inside a solenoid, the magnetic field of the solenoid magnetizes the iron, creating a strong temporary magnet. Device is called electromagnet. So basically reason it is called the electromagnet, because its magnetism is induced by the electric current in the solenoid. So if you put some soft iron core inside the solenoid, it behaves like a temporary magnet. Why temporary? Because if you switch off the current, the magnetism almost lost immediately. Okay, maybe there is very weak magnetism left, but mostly it is gone. 99% the magnetism is gone. Okay, that is why it is called electromagnet. It is basically induced by the current flowing through the coil. Right, the magnetic field lines inside the solenoid are parallel and equidistant, indicating the uniform magnetic field. Outside the solenoid, the lines spread out, resembling the magnetic field of a bar magnet. So this is the diagram given here. You can draw the same diagram given in your textbook as well. Now let's move on to the 5 marker section. A potential difference across a circuit component is reduced to 1/3. So potential difference, very easy question. Potential difference is reduced to 1/3, not reduced by. What is the difference between reduced to 1/3 and reduced by 1/3? Reduced to 1/3 means V, suppose the initial voltage was V, it is now the new value is V by 3. Reduced to 1/3. Reduced by 1/3 means, if say this is the 2, if they say reduced by, very careful, the English language is very tricky sometimes. So reduced by 1/3 means V minus V by 3. Okay, that is 2V by 3. So reduced by means this is reduced by. Reduced to means directly multiplication. Okay. So these are the difference you have to be careful about in the exam. We do not know what type of questions they might ask, so but you have to be ready for it. So the potential difference across a circuit component is reduced to 1/3 while its resistance remains constant. What happens to the current flowing through it? Name and state the law used to answer this question. Obviously Ohm's law. Draw the schematic diagram of a circuit with a 6-volt battery, a 5 ohm resistor, a 10 ohm resistor and a 15 ohm resistor, and a key connected in series. Calculate the current through the circuit and the potential difference across the 10 ohm resistor. Let me draw the circuit over here. Okay, so what we have, circuit diagram is easy to draw. 6-volt battery, we have 6-volt battery, so we will start with 6-volt battery. Now it is a battery, not a cell, so you have to add at least 2-3 layers. Okay, 2 layers is minimum. Okay, like this. Cell is this is a cell, this is a cell. Okay, battery is when you have more than one cell. Okay, so battery is generally denoted like this. Okay, one small, one large. Now if you are starting with large, you have to end with small in between. You can add few more small and large alternatively. That is a battery. This is a battery, this is a cell. This is a battery. Okay, be careful. If they say battery, you have to draw battery. Now with a 6-volt battery and a 5 ohm resistor, a 10 ohm resistor and a 15 ohm resistor. So how many resistors are there? 5, 10 and 15. So 5, 10 and 15, all of them are connected in series. So 5 ohm, 15 ohm and then 10 ohm. Sorry, 5 ohm, 10 ohm and 15 ohm. So these are the 3 resistors and all of them are connected via a key. So key means how to draw a key. So this is how you will draw a key, right? This is the circuit: 5 ohm, 10 ohm and 15 ohm, right? All connected in series. So this is the circuit diagram that you have to draw for this problem. We'll do the mathematics in the next part. Okay, now let's see. First is obviously V is equal to IR. If V becomes V by 3 and R is constant, then obviously I will become I by 3. Easy. So V equals to IR. Okay, now if you divide both sides by 3, then you will get I by 3 into R. Now if voltage is becoming V by 3, then current will also be reduced by 1/3, right? Reduced to 1/3. So if voltage is reduced to 1/3, current will also reduce to 1/3. Okay, now the law that governs is basically Ohm's law. The current flowing through a conductor is directly proportional to the voltage across it, provided the resistance is constant, or you can say that if temperature and other physical constants remain same, then the current through a conductor is directly proportional to the voltage. Okay, now in this case, if you consider this circuit, so total resistance is 5 plus 10 plus 15. Why I am doing plus? Because they are all connected in series, so total resistance will be 30 ohm. Okay, now let's see. So total resistance is 30 ohm. Now you can calculate the current in the circuit. So current in the circuit turns out to be 0.2 ampere. Now they have asked you what is the potential difference across 10 ohm. So potential difference across the 10 ohm is basically you have to multiply with the current along with the specific resistance. So first we will use all the resistances to calculate the current. Okay, then we will use the specific resistance to calculate the voltage or power, whatever they have asked you. Okay, that power or voltage is specific to that resistance only. Okay, and in that case you have to use the total current in the circuit. That current is same for all the components. So current into resistance is basically 2 volt. The schematic diagram includes battery, resistors in series and a key. Now let's move on. This is the OR question of the previous question. Same question has a OR part for part B only. Okay, define 1 volt, a copper wire with the part A is compulsory, part B has a OR question. A copper wire with a diameter of 0.2 millimeter and resistivity 1.6 into 10 to the power of minus 8 ohm meter is used to create a 14 ohm resistor. What is the required length of the wire? How does the resistance change if the diameter is doubled? Okay, we will see that answer in a while. So 1 volt is the potential difference when the work done to move 1 coulomb of charge between 2 points is 1 joule. So if you are doing 1 joule work to move a 1 coulomb charge between 2 points, then the potential difference between them is basically 1 volt. Whatever language you choose, you have to be careful. Okay, 1 coulomb charge, 1 joule work, the potential difference between the point is 1 volt. Okay, now resistance is given by rho, L by A. Rho is resistivity, L is length, A is area. Now in this case they have given you the radius of the wire. So from the radius you can calculate what is the area. So area you have to calculate, so you need a little bit calculative ability to solve this question. So this question, even though simple, but it requires some calculative abilities. Next is you have to from this formula you find L is equal to RA by rho, and from there if you put the values you can calculate the length to be 27.5 meters. Now the last part is easy. Okay, when the diameter is doubled, area increases 4 times. Okay, if you double the diameter, so if you double the diameter, okay, what is the formula for area? Area is basically pi r square. Okay, so pi r square means pi d by 2 whole square. So this is the initial area. What is the final area? Final area, say this is A1. Now A2 will be when you double the radius. If you double the radius, the area will be 2d by 2 whole square, that is pi d square. Pi d square. Now pi d square is definitely more than that of pi d square by 4. So this is the area, new area. And what is the old area? Old area is pi d square by 4. Why by 4? Because 2 square is basically 4. So now what is happened here, the area is now 4 times the initial value. So area is now 4 times the initial value. That means if area increases 4 times, from here you can see that if you increase the area, resistance will decrease. If area increase by 4 times, the resistance will decrease by 4 times as well. Okay, direct relationship. So you have to put that divide by 4, so you will get 3.5 ohm. Okay, now 4 marker question. Last question. Reflection and mirrors are integral to optics. Answer the following. So no statement, small statement, and then they have directly asking the question. Define the principal axis of a concave mirror. A ray parallel to the axis passes through the focus 10 cm from the pole. Find the mirror's radius of curvature. Okay, an object is placed 10 cm from a convex mirror, that is f equals to 15 cm. Find the image position. Or C part 2, so C part 2 is basically or for C part 1. A mirror forms a virtual erect diminished image. Identify the mirror, draw its ray diagram. Let's see. So the principal axis is the symmetry line of the concave mirror. This is the easiest definition, or you can say that if you join the pole and the radius of curvature, center of curvature, then the line that you get is basically the principal axis. It is also symmetry line. Why symmetry line? So why the definition we give by symmetry line? Because suppose this is the mirror. Now if you rotate the mirror like this, now principal axis we generally draw like this. Now what will be the principal axis for this mirror? Principal axis will also change. So basically this line divides the mirror into 2 equal halves, equal parts. Okay, that is why it is called the line of symmetry. Okay, you have learned symmetry, right, in your mathematics. So this is called line of symmetry. So basically the definition is principal axis is the symmetry line for a concave mirror. Now resistance is basically given by 2 into f, sorry, not radius resistance, my mistake. Radius of curvature is given twice of the focal length, so that is 20 centimeter. Now you can use the mirror equation. So and you calculate the V is 6 centimeter. So now if you see the V is positive, I think they have made some mistake in the sign convention. Okay, let's see the sign convention. Okay, so an object is placed 10 centimeter from a convex mirror of focal length 15 centimeter. Okay, find the image position. So convex mirror, okay, sorry, convex mirror, right? So convex mirror means focal length is positive. So focal length is positive for convex mirror, and u is given as minus 10. Okay, so you have to calculate the v. So let's calculate. So u will be 1 by 15 equals to 1 by v minus 1 by 10. So v will be 1 by 15 plus 1 by 10, that is 1 by v will be, that is 150 divided by 25, so it will be 1 by 6. So v will be 6 centimeter. So this is a convex mirror. So convex mirror forms virtual image. Virtual image is on the right hand side of the mirror. So if this distance is negative, okay, this is negative, then this is positive, right? So we already learned about sign convention in mirrors. So from there we can say this is a virtual and diminished image. Why diminished? Because object distance is more than that of the image distance. So image distance determines the size of the image. If the image distance is less than that of the object distance, size will be always diminished, right? It will be also be erect image. Now convex mirror always produce virtual, erect and diminished images, useful for wide field of views. Wide field of views means the rear view mirror of your car, or if your bike, or if your cycle, whatever you drive, if you see a rear view mirror in there, that is basically a convex mirror. Okay, so we have reached at the end of this lecture. Whatever doubts, questions that you might have, please post it in the comment below. I will be back with new videos for you in future. Till then, bye.